cloud to the cloud. Okay, so how we're going to end our time in the first unit as we've gotten ready for the test. This is section 2.4. It's the final section in this unit. And what we're going to do is we're going to revisit graphing, but this time we're going to graph inequalities. So for instance, my first example, I've got one example. I'm going to have you do 2 or 3, and then we'll each have one final thing to do. So we should plenty of time, probably have time for a couple questions if anybody's got questions to finish up with. So what we're going to do is we're going to graph negative 5x plus 2y is equal to, or no, not equal to, is greater than 4. The first step is 90% of the work, and you already know how to do this. So how do I graph inequalities? Step number 1, by the way, if your math destiny is to take you into college algebra, we come back on graphing inequalities of different types of graphs. The steps are exactly the same. You will see me tell you this same thing in college algebra. So if you have me, I would love you to be in my class. You might never want to see me again after this semester. I wouldn't blame you, but we will do the same thing. Step number 1 is we are going to graph the boundary equation. This is step number 1 to graphing that inequality. We are going to graph the boundary equation. Now, you might be saying, what is the boundary equation? That's a great question. The boundary equation, all you do is you take what I've given you, the negative 5x plus 2y is greater than 4, and you change that greater than to an equal sign. So I'm going to say negative 5x plus 2y equals 4. We're going to graph that, which is something we've already done many times in this class. You are welcome to graph however you want. If you want to graph using the intercepts, go for it. If you want to graph by plugging in points, feel free. I am going to use the slope and the y-intercept. To get the slope and the y-intercept, I solved this for y. Okay, we did this. This was our review problem at the top of the class today. And so I have 2y is equal to 5x plus 4. Divide everything by 2, and I get y is equal to 5 over 2x plus 4 over 2, and 4 over 2 is just 2. This, what I just did right here, hopefully that looks familiar. If you haven't quite gotten there on the homework and the quizzes yet, that's what we did in class last time. So my slope of this line is 5 over 2. My y-intercept is 0, 2, and I'm ready to rumble. I'm ready to graph the boundary. Now, if you're ahead of me and you're plotting the points, don't connect the dots, okay? Wait. My y-intercept is 0, 2. My slope is 5 over 2. That's 5 in the y, 2 in the x. So 1, 2, 3, 4, 5 in the y, 2 in the x. I don't really have enough room to go up again, so I'm going to go down 5. And I'm going to go left 2. I'm not connecting the dots because that's step 2. Step 1, graph the boundary equation. That's what we already hopefully know how to do. That is the 90% of the work. Step 2 is I've got to connect the dots. And you have a choice. Are we going to use a solid line? Or are we going to use a dotted line? And the answer is very much like the first day we were together or second day we were together, we were graphing inequalities, and I asked you, do you put an open circle or do you put a filled in circle on the graph? Does anyone remember what the filled in circle represented when we colored it in? Same as, equal, yes. And what did the open circle represent when we didn't fill it in? There's no equals, yeah, there's no little line. Same thing. A solid line is like a filled in circle. There's equal. I didn't leave myself enough room. I'm really sorry. So I'm going to write it a little slanted here, equal. The dotted line means that there's no equality. Same sort of thing. So for my inequality right here, negative 5x plus 2y is greater than 4. How am I going to connect the dots? Am I going to use a solid line or a dotted line? Perfect. Thank you. Lots of voices. That makes me happy. So, that was my picture side of that with more hair. Sorry, everybody. I didn't mean to traumatize you. So I'm just going to do a dotted line here. Put my arrows on it. There's my boundary. One more step. So we graphed the boundary equation. We got the points by just doing what we've already done. The next 2% of the work is connecting the dots. You got to choose either a solid or a dotted line. And then step 3, since this is an inequality, I have to shade. And what this means is either the points above the line satisfy the inequality, or the points below the line satisfy the inequality. Okay, the boundary line, it's called the boundary because it divides the Cartesian plane into 2 halves. And so either the points above it or below it, I need to shade because they represent the answer. Now, please do not do this. Do not say, oh, that's a greater than, so I'm going to shade above. That is not the case. I can change one sign on this and the greater than could be shaded below, I promise. Okay, so don't just make that assumption. What you have to do, and what we're going to do, is we're going to pick a test point. What that means is I'm going to pick a point that's on either side of the line, and I'm going to test it in the inequality, and I'm going to see, is it a solution or is it not a solution? Now, for your notes, I'm going to write this. Your test point cannot be on the boundary. Has to be on one side or the other. And I don't know if you've figured this out about me in the 2 weeks that we have known each other, but I am fundamentally mathematically lazy. I like to not do more work than I have to. So when I am able to, I like to pick the origin because it's 0, 0. I love to plug 0 in. But you can plug in absolutely any point. If you don't want to do 0, 0, and you maybe want to do 5, 5, this point right here, plug in 5, 5. If you want to do negative 6 and 4, plug that in, okay? You're picking a test point to represent all the points on one side or the other. I'm going to pick 0, 0, okay? 0, 0 is going to be my test point, okay? I'm just going to make a little dot here, and I'm just going to label that my test point. You don't have to do that on your graph. This is just for your notes. And so here we go. I'll slide my paper up in just a minute. I've got negative 5 times 0 plus 2 times 0 is greater than 4. And I want to know, is that going to be a true statement or is that going to be a false statement? Well, again, the reason I like to plug in 0 is because 0 times anything is 0. So negative 5 times 0 is 0. 2 times 0 is 0. So I just have 0 on the left is greater than 4. Is 0 greater than 4? Is that a true statement or a false statement? That's false. Oh, let me keep that there in case anybody's still writing. So 0 is not greater than 4. That's a false statement. And so here's how to interpret that. My test point is right where the tip of my pen is. I got a false statement, meaning that the test point did not satisfy the inequality. So where do you think I'm going to shade? Am I going to shade on the same side as the test point where I got the false statement, or am I going to shade on the other side of the boundary? Other side. What this means is where my test point is, that was the representative. All of these points are going to be false. I am not going to shade where my pen is because that's the false side. Those are the ones that don't create a true statement. So that means shade over here. So you can see my shading is lovely and glorious. There it is. Now you might be saying, Bergster, prove it to me. I don't blame you. I would be saying the same thing. So I'm just going to pick a point. You do not have to do this. You don't even have to write this down. I just want to show you that if you had picked a point like, let's say, -3, 3 in green, -3, 3. Let's plug in -3, 3 and see. I should get a true statement over here because I just shaded all this. So x is -3, y is 3. So I got -5 times -3 plus 2 times 3. That was my ordered pair, -3, 3. I want to know, is that greater than 4? -5 times -3 is 15. 2 times 3 is 6. What's 15 plus 6? Is that bigger than 4? Yeah, that's true. Well, that's why we shaded that side. That's where the trues are. Okay, I'm going to give you one to work through, and then we'll have another one to work through, and then we'll see where we stand at that juncture. So what I would like you to do, please, is to graph the following inequality. 2x minus 3y is greater than 6. I'm going to get started. You keep working if you're working. Not trying to rush you. So the first thing, step 1, is I'm going to graph the boundary equation. So 2x minus 3y equals 6. So I'm going to solve that for y by first subtracting 2x. And I get -3y is -2x plus 6. Divide by -3 on both sides. And I get y equals -2 divided by -3. A negative divided by a negative is a positive 2 over 3x. 6 divided by -3, a positive divided by negative is -2. So my slope is 2/3. My y-intercept is 0, -2. So 0, -2, I'll make a dot right here. My slope being 2/3 means 2 in the y, 3 in the x. So 2 in the y, 3 in the x, 2 in the y, 3 in the x. One more time, 2 in the y, 3 in the x. All right, here's the new bit. That should be review, I'm hoping. You're getting better at that. The new bit. 2, do I connect these dots with a solid or a dotted line? Okay, this time I do dotted because there's no equal sign on that. So I'm going to connect them with my ID face down so that no one gets disturbed. And there it is. And then the last thing you have to do is you've got to shade. So I'm going to pick my test point. Again, you are welcome. You tell me, pick a test point. I want to use what you used. Give me a test point.
0, 0.
Oh, I love it. It's almost like somebody recommended that to you. 0, 0. But again, if you used anything, fine. You should come to the same conclusion as me. 0, 0 is on the top of the line. Okay, whoops, the top of the line right here. So if I get a true statement, I will shade at the top. If I get a false statement, I will shade below. So we've got 2 times 0 minus 3 times 0 is greater than 6. Is 0 greater than 6? That's false. So my test point is right where the tip of my pen is. It was false. So once again, that tells me to shade the other side. So I'm going to shade below. And please notice, this was a greater than problem, and I'm shading below. All right, I've one more for you, and then we've got one more example we're going to work together. Okay, so here is your second to last problem of the day. I would like you to graph this inequality. X is greater than or equal to 8. All right, step 1, the boundary equation. The boundary equation is x equals 8. Well, hopefully that triggered a warning bell in your brain. There's no y. Does anyone remember what kind of line x equal to 8 is? It's a vertical line. If you needed to fill in a table, that is totally fine. Remember, I told you, you don't have to memorize that. You can use a table. It's a vertical line. Am I going to use a solid or a dotted line when I create my vertical line here? Why is this one going to be solid? Because of this equal bar, okay? Because of that equal bar right there, it's going to be solid. So here's my vertical line, and then here is x equal to 8. You told me solid, so there it is. And then on which side, now vertical and horizontal lines are nice. I mean, you could pick a test point, but they're more intuitive. Which side of the graph, the left or the right, are the x values bigger than 8? Yes, the right. I had to wait a second. I don't know my right from my left. I always have to, I don't know if you've noticed. You probably haven't. Anytime I say the word right or left, I have to make my hands, because your left hand makes an L. So I'm always making an L. Anyway, You know more about the Perkster now than you wanted to, I'm sure. Okay, so we're gonna shade to the right. So we shade this because it's x is greater than 8. Notice there's a 10 right there. That is bigger than 8. So I'm going to shade over here to the right. There we go. Here's our last problem for the day. We're going to work this one together. The last thing for the day is we are going to do what's called a compound inequality. There is nothing new here. Here's the example. We are going to work together in phases. We are going to graph y is less than or equal to 2x minus 3 and y is greater than or equal to negative 5. A compound inequality has 2 or more inequalities. You're in this class, it'll just be 2. Not trying to torture you, just trying to teach you something here. All you do, here's the process. You graph both, and then you determine where they overlap. So basically, it's a 2-for-1 problem. I'm going to put one of these on your test. It's simply a 2-for-1 problem. You're going to do 2 graphs on one grid, and then you're going to see where they overlap. So what I would like you to do first, I'm going to give you a couple minutes to do this. Graph the y is less than or equal to 2x minus 3. Okay, y is less than or equal to 2x minus 3. Graph that. You don't have to do the other one unless you want to get ahead and do it. That's fine. But graph the y is less than or equal to 2x minus 3. All right, step 1 is we're going to graph the boundary equation, which is y equals 2x minus 3. I tried to save us a little bit of time on this one by already giving it to us in slope-intercept form, so we didn't have to rearrange things. So the slope is 2 or 2 over 1. The y-intercept is 0, negative 3. So 2 over 1 and 0, negative 3. So my y-intercept is negative 3. And then 2 over 1 means 2 in the y, 1 in the x. So 2 in the y, 1 in the x. 2 in the y, 1 in the x. I'm going to do one more time. 2 in the y, 1 in the x. Step 2. Am I going to connect those dots with a solid or a dotted line? It's solid because of the equal bar in my original problem. So I'm going to use a solid line. Now I am going to pick a test point, and I'm going to see which way I shade. Give me a test point. Okay, it doesn't have to be, but I like your enthusiasm for 0, 0. Okay, you can feel free to use something different. You are not bound by that. So I'm going to put in 0 for x, 0 for y. So the 0 is less than or equal to 2 times 0 minus 3. So that's 0 is less than or equal to negative 3. Now think carefully on this one. Is 0 less than negative 3? Is that true or false? That's false. 0 is bigger. I'd rather have $0 than owe somebody $3. So that is false. So my test point was up here, 0, 0. We got a false statement. So that means the solutions are on the other side. So I know you probably don't have different color pens. So when you shade, I would just shade in one direction like this, so that it's going to be easier to determine where things overlap. Okay, so there's my shading in that direction there. What I would like you to do now, I'm going to give you a couple minutes and then we'll just about be done. I would like you to please graph y is greater than or equal to negative 5. Okay, forget the red graph is there. Do it on the same grid. Don't worry, and then I'll tell you what our conclusion is. Step 1, the boundary equation, y equal negative 5. So y equal to a number, what kind of line is that? It's going to be solid, but before I have to know what kind of line it is. Y equal to a number is horizontal. And then yes, indeed, step 2, since there's an equal bar, it's going to be solid. You're indeed right. So I'm going to draw a solid line at negative 5. Third thing I have to do is shade. Well, again, for horizontal and vertical lines, shading is a little bit quicker. Which way is greater than negative 5? Is greater than negative 5 going to be up, or is greater than negative 5 going to be down? It's going to be up, because you can see the numbers on the y-axis. Those numbers are greater than negative 5. So I'm just shading in one direction here. And now the solution to this, okay, when you do a compound inequality, your process is no different than what we were learning, which is you just graph the inequality. I've graphed them on the same grid, and now I want to know where do they overlap. And so for this, it's where do I have both green and red? Or for you, if you shade it in one direction, where do you have the ones that are going up and where are the ones going angular? So let me just ask you as our last thing, is the solution out here on the left bottom? No, there's no shading there. Is the solution here on the left? No, those are just green, right? Is the solution down here? No, just red. The solution is where they both are. So I'm just going to shade a little darker here in between the two lines where both shadings are. All of those points in there represent points that satisfy both inequalities. And that's our answer.